be able to know the different types of angles that are formed by when two lines are cut by a transversal. So if I put two lines up here, what do you guys think cut by a transversal means? What do you think?
Is there like a line?
Okay, a line, like where would I draw it?
Like, like kind of
Connects, okay, expand on that. What's another word that we've been looking for that connects? Jace?
Intersects.
Intersects, connects, intersects. So it would kind of intersect both of them. Would you agree? So that's our transversal line. We're going to be looking at the different angles. There's a bunch of different types of angles, and we want to get those definitions solidified. Alternate angles. What does the word alternate mean when you guys think of alternate? Jace?
Like opposite. Like if it's alternate, it'd be like opposite of the one angle.
Okay, so when we're talking about the transversal, we're going to be talking about the opposite side of the transversal, like you said. Okay, so alternate angles. We're going to have alternate interior angles and alternate exterior angles. Okay, now kind of that same thought, same process, but now we're looking at exterior angles. Give me two alternate exterior angles. Yeah, Kendall. 2 and 7. The idea behind it, I'm going to have a PowerPoint playing, and as it's called Dance Transversal. So as you guys see, like it'll say same side interior, it'll go up. You're going to want to put your feet same side interior. Okay, here we go. Get ready.
Same side interior.
Corresponding. Corresponding.
We got this.
Alternate exterior. Same side interior. Alternate interior. So the learning target for today, we're going to continue looking at parallel lines cut by a transversal. By the end of the day, you're going to be able to identify the angle pairs that are formed. You're going to be able to create equations with those angles, and you're going to be able to solve those equations. What's the name of our postulate? Look at your textbook page I just gave you. Yes?
Corresponding postulate. The two parallel lines are cut by a transversal, and the pairs of corresponding angles are congruent.
I'm going to write 3x plus 1 in this angle right here, angle DCF, and then I'm going to write 11x minus 3 in angle BCD. Please give me an equation that will help me be able to solve for x and then find the measure of those two angles. Yes?
11x minus 3 plus 3x plus 1 equals 180.
Okay, 11x minus 3 plus, I'm going to write it like this, but so you know the whole thing, the measure of the whole thing equals 180. Richard, how did you know that?
Because both of it's the transversal is a straight line. So those two added.
Linear, because they're supplementary linear pairs, we know supplementary angles equal 180 degrees. Okay, now I'm going to write right here. Why was I able to do that? Jason. Corresponding angles postulate. Very good. How can I, if I erased this and was just given that information, how can I write that as an equation? Erase this. That was our first equation. How can I write that as an equation? What do you think? Scotland, what do you think?
11x minus 3 plus.
Here, would it help if I put this back in here? Okay.
Equals.
No?
No, adding. I'm adding.
We're doing these two right here, okay?
Yeah.
Plus?
Yeah, 3x plus 1 equals 180.
It's the same thing, isn't it? And the reason why we could do that was because of what postulate?
Corresponding angle.
The corresponding angle postulate. So what do we know about the same, what type of angles are those? Right here. Okay, Bubba, what are they?
Same side interior.
Same side interior, yes. And so we can say, when you have two parallel, listen, this is important. The reason why Scotland was able to write this equation right here, because when you have two parallel lines cut by a transversal, the same side interior angles are supplementary.